we use phi to measure correlation between two dichotomous variables. So variables that only have two categories. First, out of the text, we make our raw data. And here's where the information is given. So we have 10 lower intelligent people and 10 higher intelligent people. So altogether, we're going to have 20 people. So the first piece of information is that we have 10 lower people and 10 higher intelligent people. Right here. And here are the 10 higher. So that is our x value. Now we are looking for y, and that is the 7 who were willing to participate, and the 2 of the higher intelligent people that were willing to participate. So we have here our 7 of the lower, so that's y, that were willing to participate, so they got a W right here. And that means, because we had 10 of the lower, that 3 were not willing to participate. Those 3 right here. And if 2 of the higher intelligent group were willing to participate, that means that 8 of them, those right here, were not. And now we have our raw data. Both of these are dichotomous variables, so we need to change the L, H, W, and N's to zeros and ones accordingly. Now we do the same for the did they participate or did they not participate. So we coded our categories accordingly. And now we can just do our normal correlation. So the sum of the product deviations over the square root of the sum of squared x times the sum of squared y. For that we need the formula of SP and for the sum of squares. First let's get the sum of squares for each. The sum of x is 10. So that's just adding all of those here together. That's 10. The sum of y is 11. That's adding all of those. In order to get the sum of x squared, we have to square this, and we get 10, because 1 squared each time is 1. Do the same for y squared, which is 11. We know n is 20. We have 20 people, so we can just plug it into the formulas. For the sum of square x, we get 5. And for the sum of square y, we get 4.95. So it's just 11 squared minus 11 in parentheses squared, which is the same thing in this case, over 20, and that's 4.95 for the sum of square y. Now we can plug it into this formula, but we still need the sum of xy. So one more column here. So here we just have x times y. This times this is 0. This goes for all of them. 0 times 1 is 0. And then we have here 1 times 1 and so on. That's how we come up with the x times y for each of them. And then we have to sum that up again. And that is 8. So it's just adding those. So I just noticed that there's one of each missing, because that's just 19. My screen is too small to show all of them. So there's one H, N, 1, 1, 1 on the bottom missing. So if you did it yourself, you notice that. Now we just plug it in. We get 2.5 for SP. Now we just plug that in over the square root of 5 times 4.95. And that equals 0.503. Our R squared then is 0.25. So 25% of the variance in participation can be explained by intelligence level.